Hey, what's up, guys? This is Chung here. So today, let's take a look at this LeetCode problem number 1751, maximum number of events that can be attended, number 2. So you're given like an array event, right, where we have start day, end day, and the value. So basically, the ith event start at start day and end at end day. And if you attend this event, we can get this value. And you're also given like an integer k, right? Which means that the maximum number of events you can attend. So one thing to be noticed here is that you can only attend one event at a time. Basically, if you choose an event to attend, you have to wait until this event is finished. And also the end date is inclusive, right? So which means that, let's say, here's an example. Oh, sorry. And then you need to return the maximum sum of values you can receive by attending this event, right? So what does this one, the end date is inclusive mean, right? So basically, say for example, we have 3 events here, right? So the first event starts from day 1 and ends at day 2. And this event also starts at day 2 and ends at day 3. So it seems like, the 2 and the 2, the ending date and starting date is the same of these 2 events. But that means that, we cannot, once we attend the first event, we cannot attend the second event, just like this one, because so the first event, it ends like this day, right? So we have to finish this day. So basically, if we attend the first event, so the earliest day we can start another event is a day 3 here, which is this one. That's why we cannot attend this one anymore. So yeah, basically that's the idea, right, of this problem. And then so for this one, for example one here, so we have the maximum we can attend is the values we can get is 7 by attending event 0 and event 1, right? So and here we have some other examples, and here for this one the max value is 10. So all right, cool. So for this kind of like interval problems for the start and end, it's always like we should always sort, basically, but by which order, right? By start, we either sort by start date or by the end date. So for this problem, we should sort by the start date. So why is that? Because because the way we're solving this problem is that, let's say we want to let's say we attend this event 0, right? So this is the event, the 0 we're trying to attend. And after attending this this event 0, we need to find basically the first, after the event 0, what's going to be the next event we can attend. Okay. And to be able to find that, basically that's why we need to sort by the start time, because after this, the event, we have ending date, and then we can use that ending date to find the first available event that we want to attend. That's why, to be able to check that, we need to sort by the start time. And for each of the event, we have 2 options. Basically, basically we can either choose to attend this event or we don't attend, right? So if we don't attend this event, basically we can just throw the problems to the next state. So which means that now, and also we have this kind of k events limit here. So now it's kind of obvious that we can define our dp functions here, basically the dp of I and k here. And so this one means that, the maximum values, the maximum value we can get, right? We can get when at ith event, right? And has k events left. has k events left. So that's basically the definition of the DP here, right? And so how about the DP transition function, right? So basically two options, right? So I mean, the first option is that we at ith event we choose not to attend this current event. Okay, so which means that the answer, right? So we have the first answer will be the DP of I plus 1, right? And then k. Because if we choose not to attend the current event, which means that we can check the next event, which is I plus 1. And then the k doesn't change because we didn't change that. Or, right, or we can, the next one is what? It will be the max of the answer, right? Plus what? If we chose to attend this event, so first we can get the value for this event, right? And then, like I said, the next DP. The DP is what? This should be the next I. The next I here, right? And then the K will be K minus 1 because we have K minus 1 events left that we can attend. And this next I is the thing we need to find because, like I said, depending on how long the current meeting will last, right? We might need to skip some of the events down the road, right? Basically, the next I is the first event that we can attend. And from there, we just do the same thing. We can either choose to attend this next event, or we don't attend it. But the problem is that how can we find this next I, right? I mean, a brute force way is that we just simply loop through. The event starting from I here, and then we just return the first one, whose the start time is greater than end time, right? Remember, it's inclusive. So for example, if it's 2 here, the end time is 2, so we need to find the first event starting from I whose start time is greater than 3, which is starting from greater than 2, which means starting from 3. So that's the brute force way, and depending on if this current event is so big, right? So I mean, I think it's going to be a O of n squared time complexity, right? Because we are doing like a linear scan. Okay, but we can do better, right? Because obviously, since all the events they're sorted already, right? We can simply do a binary search, right? On top of that, basically we just use the end time. We use the current end time, and then we do a binary search on this assorted event. Then we can quickly find the next available events after this event. Right, cool. I think that's it. So that's everything. And to do this, and we're using a DP, top-down DP, right, with a memorization. And then let's do it. So the code is pretty short, actually. So first we sort the events, right? So by start time and then by end time. And then we have n. It's going to be a length of events. Okay, and then we define the DP, right? So the DP, like I said, is the current event I, and then we have a remaining k here. So we'll do a LRU to help us do the cache. Okay, and then here we just return the DP of 0 and k, right? Because we start from the event 0, and then at the beginning we have k events left. So some like exit point. So basically, if I is equal to n, right, which means that there's no more events left, then we simply return 0. Or like another one, right? So if k is equal to 0, right, we also return 0. It means that there's no more available event that we can attend. Then basically not attend event I, right? So we have answer equals to dp of I plus 1k, right? So that's that. And then the next one is to attend, right? Attend event I. So to attend event I, we need to find the next I of event. So we do a binary search, bisect left, So the event, right? We search on the event. So one thing to be noticed that in Python's, since event is like it's a it's a list, right? You cannot search an integer against a list. They have to be the same type. So which means that you have to convert that end time to be to the to the list. Basically, this event I1 is the end time of the current event, right? So you have to convert this one to an integer, sorry, to a list, and then so that you can use this one to search. But remember, so the end time is 2. If we do a bisect left, okay, but we cannot use this 2 as a starting time because the ending time is inclusive, which means that we have to do this one plus 1, which means that the first available event has to have this has to have the start time greater than two, at least to be 2 plus 1, which is 3. Basically, we're searching for the next event, the first event, whose uh, mm, whose start time, right, is at least 3. Because this is how binary search works, right? So let's say if we have 1, 2, and 3, right? So we have 2 here, right? So we want to search the index for the first element who is greater than 2, right? Basically, and how we do it? So we do a binary search. We do a bisect left on this 2 plus 1, which is 3. That's going to be the first item, the first index whose value is greater than 2. Right, that's how this bisect left works. That's why we do a 2 plus 1, then we'll get this index. So, and then after that, I think the rest just like we do answer equals to the max of the answer dot. So first, we need to collect the current values, right? By attending this current event, it's going to be event I dot 2, right? That's going to be the value plus the dp of now the start index is I, right? And the k will be k minus 1, right? So then we return the answer. Yeah, so I think that's it, right? Okay, run the code. Yeah, so it passed. So for this like a binary search attempt, right? So basically the time complexity for this one, what's going to be time complexity for this? So we have k. So we have like this, how many states we have? We have the total events, the event length. Okay, so as you guys can see, right, so the k times event length is less than 10 to the power of 6. Okay, so which means that this one can guarantee that the total state of this dp will be less than. So let's say the event length is n, right? So and we have a k. So the total state we have is n times k, and the n times k is not will not be greater than 10 times 10 to the power of 6. So the event is fine. Now to find this binary search, right? So this one obviously is the log n, right? Basically, so the total time complexity for this one is n times k times log n. Right, so we use the log n to search the next available I here. Yep. So I think that's it, right? I mean, no, another like classic interval plus DP problem, right? So again, right, so to solve this kind of problem, we have to decide like if either we want to sort by the start time or end time. So for this one, since we're trying to use a top-down approach, which means that if we and also the for this kind of interval problem, we have some another common approach is that we also would have two options. Basically, we either attend this event or we don't attend this event. And so for this problem, to not attend the event is simple, and but to attend this current event, we need to find the next available, basically the next event that we can, the next event we can attend. So to find that, a brute force way will be we search, we scan from the current I, and until we find the first event whose start time is greater than the current event end time. Or even better, we can do a binary search on that, and then we just do another DP on this one, right? Cool. I think that's everything I want to talk about for this problem, and thank you for watching this video, guys. Stay tuned. See you guys soon. Bye bye.